Uh, in this video, we are going to look at a couple of problems involving uh, counting and proportions. And here, the idea of Venn diagram is again useful. So let's look at the first problem. In this case, we say, okay, 30% of math club students are also in science club. Meanwhile, most of science club students are in math club. 80% of them are also in math club. And let's assume that the science club has 15 students. The question is, how many students are there in the math club? All right. If you think about it, for this particular problem, the Venn diagram is actually not necessary. But the problem setup looks like a Venn diagram type of problem, so we may as well try to draw the circles. And this, if we draw the circles, one circle is math club, another circle is science club. Let's do that. Okay. Science and math. Okay. And of course, the middle is both. So the typical idea for Venn diagram is that you try to fill up the circles from middle and then go outside. And now if you want to fill up the circle in the middle, you need to figure out the following. How many students are there in both science and math? And this actually is the crucial question for this particular problem. And the Venn diagram idea leads you right to the key of the problem, this crucial question. Well, this actually you can figure out quite simply because we know the number is some fraction of 15 because we have 15 students in the science club. And science here 15. And most of them are also in math club. And how many of them are in the math club? 80% of them are also in the math. And these students are exactly students in both math and science. So how many do you have? You have just 80% times 15. And this you can calculate, this is 12. And you have 12, you have 3. Well, how many left in this circle? Well, we have one more condition we didn't look at. We used the condition that 80% science club students in math. We use condition science as 15. The last condition, 30% of math students are in science. So let's assume we don't know what math students amount are. So let's say math is, if we don't know, we just call it X, right? And then 30% of them are in both math and science. So 30% of X. But we just figure out there are in a circle 12 students here. So it's just a simple matter of solving this equation, figure out what X is. 12 divided by 30%, 0.3. And if you divide, you get this 40. And there are 40 students in Mathcup. Of course, we can fill out the whole circle. There are 28, which is in math, and outside this little circle where in both math and science. Okay, so now let's look at this question. It's another question relating to fractions, proportions. It says, in a class, 3/4 of students like math. So that means 1/4 doesn't like math. And 3/5 like English, and 1/6 like neither. And the question is, what's the fewest possible number of students who like both math and English? You can pause to think of this problem. So what's the approach to this problem? Well, we didn't have any information about the number of students. We don't know whether there are 100 students or 20 students in the class. This information not given to us. So how do we know the number of students who like both math and English? Well, let's not worry about it. This problem looks like a Venn diagram problem. So let's just set up a Venn diagram and see what information we get. Let's draw circles. This is a circle for students who like math, for students who like English. Okay, now we also have students who like neither, so these are outside both circles. So let's do a rectangle here. And outside both circles, they don't like any. Okay, now we always want to fill from the inside out, but we don't know how many students like both math and English, and we don't even know their proportion. So let's put here the proportion, call it x. If we don't know something, we call it x. And then we can fill the rest. And for example, for English, well, it's 3/5 of the student. And of course, we need to get rid of x, but the total is 3/5. And here, for math, it's 3/4. Take away x. And outside everything, the 1/6 means they don't like math, they don't like English. So that's a picture with an unknown x. And now what do we have? Well, we have that the total, everything should add up to be 100%, should be 1. So this should allow us to figure out what x is. And that will help. So let's just do it. Figure out what x is, add everything. 1/6, 3/4 minus x, plus x, 3/5 minus x, equals 1. Okay, so how many x are there? Well, we have 1/6 plus 3/4 plus 3/5, and the total minus x plus x minus x, so there's minus x equal to 1. And here the fraction, we have this common denominator to add, and the common denominator in this case is 60. So this is 60, 10, and if you do 60 here, you multiply by 15, so that's equals 45. 60, and this is multiplied by 12. 5 times 12 is 60. 36. And we'll just subtract 1, move the 1 to the left and move the x to the right. 1 is 60 over 60, that's the 1. And this is x, okay? So this 1 becomes 60 over 60. Okay, add the numerators, 10, 55. This is the 91 minus 60. So if you add everything, you get 31 over 60. That's the x. This is the x. Okay, so that tells us something. X is 31 over 60 of the whole student population. And 31 does not have any common factor with 60, which means the least amount student, the total you have, will be 60. Otherwise, you won't get the integer. 31 over 60 times 60 will become integer, but anything smaller will be a fraction. So which means the lowest amount student you could have for the whole class is 60, and fewest amount student who like both math and English will be this times 60, and the answer will be 31.